Exercise 13.2. We have discussed standard derivatives and working rules. Now we go for examples based on this. Exercises based on this. First question, I'll go to 11th. Differentiation of sin x into cos x. So I'll write d by dx of sin x into cos x. What we do? We use the product rule. Sin x as it is, differentiation of cos x, plus, always plus, now cos x as it is, and d by dx of sin. This is known as which rule? Product rule. We know this is called product rule. Derivative of one function, the other function as it is, plus now cos as it is and derivative of sin. Sin x as it is, what's the differentiation of cos? Minus sin, plus cos x as it is, what's the derivative of sin? It is cos x. So from this, here this is cos squared minus sin squared. You know that this is nothing but sin 2x. Cos 2x. So derivative of sin x into cos x is nothing but the cos 2x. You see, I've started with differentiation. The important one is working rule and all standard derivatives. What about the second one? The second one is just which function? Sec x. So standard formula, d by dx of sec x. What is derivative of sec x? It is sec x into tan x. It's a just formula, it. We already stated it earlier. Fine. Third one now. Third one. Which function you are given in the third question? You are given 5 into sec x plus 4 times cos x. So d by dx of 5 sec x plus 4 cos x. We are differentiating. 5 being constant as it is, derivative of sec. What is that? Sec x into tan x. Very simple question. Plus 4 being constant as it is. What's the derivative of cos? It is minus sin. So finally we are getting 5 into sec x into tan x minus 4 times sin x. This is required derivative. Fourth one, that is again standard formula, that is cosec x. So d by dx of cosec. What is derivative of cosec? It is minus cosec into cot. It's just a standard formula. Derivative of cosec x is cosec into cot with minus sign. Whenever you see, then always you have minus sign. It. Okay. Next. What about next? Let's go to, I'll go to 6th. 5th you can try. You have 5 sin x minus 6 cosine x plus 7. This is a function. You want derivative of this. So d by dx of this function. Derivative of this function. 5 being constant as it is. What's the derivative of sine? It is cos x. Minus 6 being constant with the function as it is. Differentiation of cos. What is derivative of cos? Minus sine. See first, minus sine. 7 being constant alone, derivative is 0. If you are constant alone, then the derivative is 0, which we know. So finally 5 cos x plus 6 sin x plus 0. So this is a required derivative. Next, here 7th, 2 tan x minus 7 sec x. Again standard function. So I'll just write directly without putting symbols. 2 as it is, what's the derivative of 10 sec square? Minus 7 as it is, what's the derivative of sec x? Sec x into tan x. This is a required derivative. I just wrote directly without putting symbol. You can write in detail. Okay. Now we go to question number 9. which is again based on formulas and working rules. So 9th question. Question number 9, first one. So there the function is 2x minus 3 by 4. Read the question. What's the question? Find the derivative of this. So we want d by dx of 2x minus 3 by 4. 2 being constant with the function as it is. What's the derivative of x with respect to x? 1. Minus 3 by 4 being constant alone, derivative is 0. So required derivative is just 2. Fine. Next, let's go to second one here. What about second one? There you have 5x cube plus 3x minus 1 into x minus 1. You have product of two functions. Here you have product of two functions. I'll use the product rule. Let me write d by dx of 5x cube plus 3x plus minus 1 into x minus 1. This one as it is here. Product rule we are using as we did in the first question. Derivative of this d by dx of x minus 1. Always plus sign. Which one as it is now? X minus 1 as it is. D by dx of which function? 5x cube plus 3x minus 1. So now we are differentiating. Here we have just used the product rule. 5x cube plus 3x minus 1. Differentiation of this, derivative of x with respect to x is 1. Derivative of 1 being constant, 0. Plus here x minus 1 as it is. Differentiation of this 5 as it is. What is derivative of x cube? 3x squared. So this is 15x squared. 3 being constant with the function as it is. What is derivative of x with respect to x? 1. What is derivative of 1? You know it is 0 here. So differentiation is over. Now you just need to simplify. This one as it is here, 5x cube plus 3x minus 1 as it is. You open these brackets and simplify. So you can have the final expression. Okay. I'll go to now third sub question here. Let's go to third sub question. What about third sub question? X raised to minus 3 into 5 plus 3x. I'll just open the bracket. So 5 into x raised to minus 3 plus 3 times. Here 1 power and here minus 3 power. So minus 2 power. Now I'll differentiate this. I'm going to differentiate this. So we just put d by dx in front of this. So we have here d by dx of 5x raised to minus 3 plus 3x squared, 3x raised to minus 2. How will differentiate this? Using this formula. What is derivative of x raised to n? Derivative of x raised to n, that is n into x raised to n minus 1. We'll use this concept. Differentiation of x raised to n. So 5 as it is, minus 3 will come in product, minus 3 minus 1. Plus 3 as it is, minus 2 will come in product, minus 2 minus 1. So let's simplify this. If I simplify, I hope this is clear to you. At both the places I have used this formula. Power will come in product and one less power. So this is minus 15 into x raised to here minus 4. And this is minus 6 into x raised to minus 3. So you have minus 15 by x raised to 4 minus 6 by x cube. Differentiation is over here. We are just simplifying. You can take minus 3 by x cube common. So you will get the 5 by x here plus this is just 2. That's derivative. D by dx equals to this. You can see this. Fine. Differentiation is almost over here, remember. This is simple algebra. Let's see the next. What about next one? fourth is just same question. I'll be having here x raised to 5 3 minus 6 into x raised to minus 9. So this is 3 into x raised to 5 minus 6 into minus 9 plus 5. So you have minus 4 power. Now we just differentiate it. We are differentiating this. So I'll write here d by dx of 3 into x raised to 5 minus 6 into x raised to minus 4. 3 being constant as it is, differentiation of this one is 5 into x raised to 4 minus 6 into minus 4 into x raised to minus 4 minus 1, so minus 5. So 15 into x raised to 4 plus 24 upon x raised to 5. That's derivative here. Here, over here as well as over here, we have used the same formula. Derivative of x raised to n is n into x raised to n minus 1. 1 less power 4, here 1 less power, so minus 4 minus 1, so we'll get the minus 5. That is the required derivative. Okay, now we let's go to sixth sub question, that is about division rule. So let's do that. Sixth sub question. You are given this function 2 upon x plus 1 minus x squared upon 3x minus 1. Division of two functions. We differentiate this. This is a question. d by dx of this. Okay. So differentiation of the first one, d by dx of 2 upon x plus 1 minus, this is very standard working rule, differentiation of the other one. This is subtraction rule. For addition and subtraction, you can take derivative directly inside the bracket. So we have this. Now for both of this we use the division rule. What is the division rule? Square the denominator function. Here x plus 1 as it is. And now differentiation of 2, which is 0, constant alone, always minus sign. Now which one as it is? Over here 2 as it is, and differentiation of x plus 1, derivative of x is 1, 1 is 0, so we have just 2 minus, same thing here. What we do? Square the denominator function, x minus 1 the whole square. 3x minus 1 as it is, differentiation of x squared, which is 2x, minus, which one as it is? X squared as it is, differentiation of this, derivative of x is 1, 3 being constant as it is, so this is just 1 and derivative of 1 is 0. So 3 into 1, so I suppose this is 3. Now we simplify this. This will be 0, so you have minus 2 upon x plus 1 the whole square. Here, if you just take x common, so this is 6x minus 3x, so we'll get 3x, and this is minus 2, just simplify, upon 3x minus 1 the whole square. That's derivative of this function. I'll just remind you, we have used this division rule, d by dx of fx upon gx. I've used this twice. What is this rule? Square the denominator function. Then this one as it is. So I've kept x plus 1 as it is. d by dx of fx. fx means 2 here, which is 0. Minus, now you need to interchange. Now fx as it is. So 2 as it is here. Into d by dx of gx. gx means x plus 1. Derivative of 1 is 0, derivative of x is 1. So it is derivative of here gx. This is what we have stated as division rule. Same thing here. Okay. Now, 8th question. Question number 8. What's the question? Find the derivative of this function. X raised to n minus a raised to n upon x minus a. D by dx of this. So repetition of above thing, you have division rule. So x minus a the whole square, then x minus a as it is. Differentiation of which function? Numerator function. What is derivative of x raised to n? You know, n into x raised to n minus 1. What is derivative of a raised to n? This is a constant, so 0. Minus, now that bracket as it is, x raised to n minus a raised to n as it is. What is differentiation of x? 1. What is derivative of a? 0. So we have just 1. Differentiation is over by which rule? Division rule. Right? You have used this. Differentiation of x raised to n is n into x raised to n minus 1. That you have used. Derivative of a raised to n is 0 because it is a constant. Now we just simplify the numerator expression. I'll open the bracket here. Here 1 power, here n minus 1 power. So n into n minus 1 and 1. So x raised to n minus a n x raised to n minus 1 minus x raised to n minus plus a raised to n. I repeat what I did here. I have just opened the bracket. This n as it is. Here 1 power, here n minus 1 power. So x raised to n, a n x raised to n minus 1 here, minus x raised to n plus a x raised to, here a raised to n. That's required derivative, d by dx of this function. Now next we go to 7th question, which is also a very simple question. X minus a into x minus b. What is the question there? For some constants a and b, find the derivative. So d by dx of this. So which rule? One way is you can open the bracket and you can differentiate it. The other way is product rule. So here x minus a as it is. Differentiation of this. Derivative of x is 1, derivative of b is 0. Minus x minus b as it is. Differentiation of x is 1, derivative of a is 0. So it is just 1. So you will get here, sorry, this is plus sign here. So 2x minus a minus b. In the product rule always you have plus sign, you know. I'll go to third now. Second you can try, just open the bracket. Second you can do like this. You are given ax square plus b the whole square. So expand it first. So you have a square x raised to 4 plus 2abx square plus b raised to 2. This is simple expansion. Now we differentiate it. So a square being constant as it is with the function, differentiation of this one 4x cube. 2ab constant with the function as it is. What's the derivative of x square? 2x. And differentiation of b square being constant alone, derivative 0. So this is your answer. You can just take common from this. Fine. Okay, I'll go to third one. D by dx of which function? X minus a upon x minus b. Which rule? Division rule. So squared the denominator function, you know. X minus b as it is. Differentiation of numerator. Derivative of x is 1, derivative of a is 0. So 1 minus. Now x minus a as it is. Differentiation of this one is 1 and this is 0. So we have this. So if you open the bracket here, x will get cancelled. We'll get just minus b plus a upon x minus b the whole square, which is our required derivative using division rule. Question number 6 now. 6th question. You are given a polynomial function there. X raised to n plus constant x raised to n minus 1, a square x raised to n minus 2. This is a constant. A raised, is to n minus 1, this is constant, into x plus a raised to n, this is constant alone. We want derivative of this. So here d by dx of this expression. This is a question. D by dx of this. How do you differentiate x raised to n? N into x raised to n minus 1, one less power. A being constant as it is, differentiation of this one. N minus 1 x raised to n minus 1 minus 1. Using which rule? This one. What is the derivative of x raised to n? N into x raised to n minus 1. This way we used. Plus a square as it is. N minus 2 into x raised to n minus 2 minus 1. One less power. Now, and so on, come to second last. A raised to n minus 1 being constant as it is. Differentiation of x with respect to x1. A raised to n being constant alone. This is a constant. X is not there, means it's a constant. Whenever x is involved, it's not a constant. Your x is not involved, means it's a constant, so derivative is 0. So finally we are getting this n into x raised to n minus 1, a into n minus 1 x raised to minus 1 minus 1, so n minus 2, plus a square into n minus 2 into x raised to n minus 3, and so on. Finally you have here a raised to n minus 1. Final derivative of the given function. Now question number 5, fifth question. In the fifth question you are given a function. Which function we are given? It's also polynomial here. X raised to 100 upon 100 plus x raised to 99 upon 99, and so on. X raised to 2 upon 2 plus x plus 1. We are asked to prove something, but before we do that we need its derivative. So we just differentiate this. So I'll write f dash x. F dash x means its derivative. Here no need to use division rule. 100 is constant, so 100 as it is. 100, actually it's 1 by 100. You can imagine like this. 1 by 100 into x raised to 100, like this. So this is constant as it is. You are going to differentiate just x raised to 100. What is derivative? 100 into x raised to 99, one less power, plus 99 being constant with the function as it is. Differentiation of 99, 99 x raised to 98, product, one less power, upon 2 being constant as it is. What's the derivative of x squared? 2x. Derivative of x with respect to x, 1, and derivative of 1 is 0. So here finally 99 x raised to 98, and so on. Finally x and then 1. This is f dash x. Therefore we have this. Now what is left hand side? F dash 1 LHS, that is f dash 1. So we have 1 raised to 99, 1 raised to 99, 1 and plus 1. Now this is just 1, 1, 1. How many times? Can you predict? Do you understand what do you mean by f dash 1? F dash 1 means what? In the derivative, instead of x you put 1. In the derivative, instead of x you put 1. So 1, 1, 1. Now how many times this 1, 1? Can you predict? You see, here it is x raised to 1, then x squared till 99. So this 99 and this 1, so total 100, remember. This is 100 times. Just observe carefully. This will be 99 and plus 1, so 100. What about RHS? Right hand side? Right hand side is 100 into f dash 0. 100 as it is. F dash 0 means what? Instead of x you put 0. So 0 plus 0, 0 plus 1. So this is just 1, so you are getting 100. So if you just observe these two, you can say that f dash 1 equals to 100 into f dash 0. Fine. Now we go to first 3 questions, which are very, very simple questions. Question number 1 there. Which function you are given? Fx equals to x square minus 2. We want its derivative at 10. So we differentiate it. F dash x 2x 0 at x equals to 10 unit derivative. So we put 10 here, so it will be 20. Fine. Second question, which function you are given? X, fx equals to x. So we differentiate it. What is f dash x? It is 1. Derivative of x with respect to x, you know it is 1. Now you are asked at which place at x equals to 1, but here it is already constant, so answer will be 1 again. Third question, third sub question, there you are given fx equals to which function? 99x. So differentiate it. What is f dash x? 99. Differentiation of x with respect to x is 1. Now you are asked at which place at x equals to 100. This is not important because this is a constant. So answer will be 99 only. Here this is a constant. So whether it is 1 or 2 or at any place, the final derivative will be 1 only. Here derivative depends upon x. So that's why we could place x equals to 10 and finally we are getting 20. Here derivatives are constant, so whether it is 1 or at any place, the final will be 1. Here derivative is 99, so whether it is at 100 or any other place, derivative will be 99 only. Fine. Now question number 4, there we have 4 sub questions, and question number 10, both are based on first principles. So let's do that. We just need to recall definition of first principle. So question number 4 and 10 are about these 2 questions are based on first principle. So using definition, first principle means what? Using definition. And definition means limits. Okay. So if you recall, f dash x is this limit h tends to 0, f of x plus h minus fx upon h. This is the definition. So we are going to use this in both these examples. So here first, what is fx? Question number 4, first one, the function is given by x cube minus 27. You know directly derivative. What's the derivative? X cube derivative 3x square, 27 0. So final derivative is just 3x square. Okay. Now recall the definition. F dash x equals to limit h tends to 0, f of x plus h minus fx upon h, as I wrote here. So now this is just a question of limits only. You have question of limit only, remember. So limit h tends to 0, f of x plus h means what? In the formula of the function, in place of x you put x plus h. So x plus h the whole square minus 27 minus fx. Fx means you copy this expression, x cube minus 27 upon h. Now what you need to do, you simplify this. You must get h common and that will get cancelled with this, because this is a polynomial upon polynomial form. So h minus 0, what is h minus 0? Which is h. So h should get cancelled from the numerator and the denominator. So I'll just expand this. 27 plus 27, obviously it will get cancelled. I'm expanding x squared plus 2hx plus h squared. Oh, sorry, this is my mistake. Here it should be cube, because here I have cube. So I will have this expansion. I'm sorry, this is cube. So x cube plus 3hx squared plus 3x squared h plus h cube minus x cube upon h. Here you should correct it. It should be x whole cube. Just we have placed x by x plus h. The cube remains same, remember. X cube will get cancelled. You can see that from the remaining terms, h is common. So here 3x squared, 3hx and h squared upon h. This will get cancelled. Now we can apply the limit. Limit depends upon h here. So 3x squared as it is. H tends to 0. This is 0. This is also 0. And finally we have this. That's what you had expected. That's what you have written here. Derivative should be 3x squared. But we did with the help of limits, which is known as which principle? First principle. Fine. Now here I'll go to directly fourth sub question. Middle two you can try. I'm sure you can do it. We have there fx equals to x plus 1 upon x minus 1. You can do directly also by division rule, but we don't want to do that way. Here we are asked by first principle. Okay, so here f dash x equals to limit h tends to 0 f of x plus h minus fx upon h. This is the definition. That's what we are using everywhere. Now, what's the meaning of this? In the above formula, instead of x, you write x plus h. That's the meaning of f of x plus h. Instead of x, you are going to write x plus h. So I have x plus h plus 1 upon x plus h minus 1. Minus fx means copy the function upon h. Now again we simplify. We cancel h from the numerator and denominator. That's all in all about the solution. Okay, so here limit h tends to 0. We are simplifying the numerator. We'll do the cross multiplication. Minus x plus 1 into x plus h minus 1 upon h into x plus h minus 1 into x minus 1. What we did? Cross multiplication. This is simple algebra which we can do very easily. Now we open the bracket. We are just opening the bracket here. So if I open the bracket, we will get x squared minus x plus hx minus h plus x minus 1 minus x squared minus here x minus sign is there, remember. Then we have minus hx, then we have minus h, and finally this minus minus will be plus, so x plus 1, both are plus, upon this expression right now as it is. H should be common from the numerator, and that we are going to cancel with the denominator. See, this x square will get cancelled. Then this minus x will get cancelled. Hx will get cancelled. What about this here? 1 will get cancelled. So in the numerator you are left with just this 2 minus 2h. Check, all other terms will get cancelled. Open these brackets, you will see that internally all will get cancelled. You are left with this minus 2h upon h, x plus h minus 1 into x minus 1. And now apply the limits, so h will get cancelled. So you have minus 2 upon tends to 0, so this is x minus 1, and this, there is no h in this, so x minus 1 as it is. So minus 2 upon x minus 1 the whole square by working rule f dash x equals to this. You can try by division rule, of course you will get the same answer. Now I have dropped that second sub question. The second sub question, what you can do, you can just open the bracket. So your function will be x squared minus 3x, and you will have what, plus 2. And now you can do like the previous two questions, right? You can take this as a function, x squared minus 3x plus 2. 10th question, function is fx equals to cos x. You know derivative of cos is minus sine. Now we want to prove this one by first principle, means by definition. So what is definition? F dash x equals to limit h tends to 0 f of x plus h minus fx upon h. This is equals to limit h tends to 0. What is the meaning of f of x plus h? In the function, instead of x you put x plus h, so cos x plus h minus fx means cos x upon h. We know that numerator is known expression. Can we just recall what is numerator? C minus c. What is c minus c? Minus 2ss, factor formula. So this is equals to limit h tends to 0 minus 2 sine this plus this by 2, so 2x plus h by 2 into sine this minus this, which is h by 2 upon that h as it is. What we have used? Factor formula. What is factor formula? C minus c minus 2ss, this plus this by 2, this minus this by 2. We also know in any limit question involving trig function, we need to use this sin x upon x. As x tends to 0, you know limit is 1. Now if you apply the limit 0, this is 0, this is 0. So we need to use the formula for this expression, this one and this one. We keep this one as it is. First one we keep as it is. Why? Because it is not 0. You put h equals to 0, it is just sin x. So we keep this one as it is right now. Here, what is angle? H by 2. So I must have the same angle, by 2 into 2. Angle should be same. You see xx. So now this much, this 2 will get cancelled. Now this much gives us 1. So this is equals to, this is just 1. And what about the other part? You apply the limit. Sine h tends to 0. So this is 0, 2x by 2. So this is equals to, sine x, and with this minus sign is already there. So with this minus sine x. So this is definition of, by definition, derivative of cos x, which is minus sine x.